Now, for all the attention that's paid to science work done by human crew members, there is a good bit of science research being conducted by instruments located on the outside of the International Space Station. The hyperspectral imager for the coastal oceans has been gathering data for nearly 5 years about the conditions of ocean waters all over the world. This morning, we're going to learn more about it from Mary Kappas, the HYCO facility manager, who joins us from her office at the Naval Research Laboratory in Washington, D.C. Mary, for starters, tell me about the hardware itself, and when was it launched, and where on the station is it located?
Okay, HYCO is a hyperspectral imager, which is made up of a camera, that is the focal plane that records the data, 4 optics for collecting the light, and a spectrometer for dispersing the broadband incoming light into separate wavelength bins. HYCO was built as a demonstration project under the Navy's Innovative Naval Prototype Program. And so it had to incorporate innovative cost-effectiveness and project acceleration methods. To do that, NRL designed HYCO based on decades of airborne hyperspectral experience that was focused on coastal oceans, and they incorporated commercial off-the-shelf parts for most of the system. We designed HYCO to capture the complexities, subtleties, and scale of ocean coastal dynamics. HYCO was built in 18 months and launched in September 2009. It's on the Japanese exposed module, the GEM, and it's in an enclosure that provides protection during ISS maneuvers and a quite dark place for acquiring dark scenes needed for calibration. There's a commercial off-the-shelf rotation stage also that allows HYCO to aim side to side.
Now, for those of us who aren't scientists, what does hyperspectral mean?
Hyperspectral means separating the incoming light into separate wavelengths in lots of separate, narrow, contiguous bands. The operative concept is separating the wavelengths. So the term hyperspectral doesn't specify the range of wavelengths, as that's different for different kinds of sensors. Now for HYCO, the incoming light source is the sun, which covers lots of wavelengths in one broad band, and HYCO records just the visible, especially the blue, through the near infrared. Specifically, it goes from 350 nanometers out to 1,080 nanometers in 128 bands that are 5.7 nanometers wide, which is fine enough to resolve features of optically active substances in water.
Now,
for one spot, that'd be 1 pixel in a collected image, you can look at a spectrum that shows how light is reflected or absorbed at each wavelength, and different materials absorb or reflect light differently based on their chemical composition, particle size, and shape, etc. So we're doing spectroscopy like chemists do in the lab, only our samples aren't neatly prepared and all in one type. We can tell whether there's a high concentration of phytoplankton or suspended sediments or other water constituents, and these elements are indicative of the health of ocean ecosystems or visibility in the water or the dynamics of flows.
And is that your specific target, phytoplanktons?
That's one of the things. It's overall what's the constituents of the water, and we look at optical properties, and then we convert that into physical properties like phytoplankton, suspended sediments, dissolved organic matter, etc. And that in turn can be converted to look at what is the visibility or the water depth, for example.
And what is the value of doing this test from orbit instead of going down to the waterfront and taking a water sample and testing it?
So, well, in addition to the spectrum for each pixel, we get a whole spatial array. Our image size is 50 kilometers by 200 kilometers. So in each scene, we basically have a three-dimensional image cube. So the spectra tell us about the material composition, and the spatial display shows the pattern of that composition. So in the coastal oceans, that allows us to see how high concentrations of some component, let's say suspended sediment, relates to the outflows from rivers, the shape of the coastline, etc. So now, really what that does is the Spaceborne location gives you this spatial extent, while your boat samples is very localized. So that Spaceborne sensor allows you to do repeat visits without having to stay on site in a boat. But I think I should point out that these two approaches work best together. We need that in situ sampling to calibrate and confirm the hyperspectral measurements, which is really the case for any remotely sensed measurement. HYCO met all its goals within the first year. The first image transmitted to Earth was a good, clean image. And since then, we've constantly worked to improve our calibration And we engage scientists throughout academia to work with the data and to help advance the processing and conduct useful scientific studies. If you want some examples, researchers have used HICO to map the contents of the water and the bottom in areas in the Bahamas and Australia. They mapped out bottom depth, bottom types, such as different types of sand and seagrass, and water constituents, such as chlorophyll. Other researchers looked in San Francisco and Monterey Bays to determine the water quality and make maps showing the extent and concentration of phytoplankton blooms and sediment plumes.
Now, I understand that HICO is now a part of the International Space Station National Laboratory. What does that mean for it in terms of day-to-day operation?
Well, it's been providing some really big pluses. The direct tie to NASA enabled us to get additional data streams to help improve our geolocation accuracy, and we were also able to get a faster data transmission rate, and that enabled us to schedule up to 2 images per orbit, and in the past we've been limited to 1. And another thing is that all the HICO data is now available on NASA's Ocean Color website, where researchers worldwide can browse and download it. And by being co-located with traditional ocean color sensor data, such as MODIS and VIIRS and so forth, that encourages new users and multi-sensor projects.
How long do you figure HICO will continue to operate?
Well, it can operate as long as it keeps working, and so far the health of the system is very good. And the other limitation would be the real estate on the ISS. So HICO's lifespan depends on whether there's other plans for that spot, and right now there's no immediate plans. So we look forward to several more years of operation from the ISS.
Well, Mary, thank you very much for this couple of minutes and teaching us about what HICO is doing there. I appreciate that.
Thank you for the opportunity.
Mary Kappas is the HICO Facility Manager at the Naval Research Laboratory in Washington, D.C.